Hello, hello. Yeah, now it's working. Hello, okay. Hello, 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 hello. So let's start. So hello guys, welcome back to stream. Okay, I think the issue has been resolved. I hope so. So today we are going to start a new series, and it's all about wireless networks, mobile and wireless network, and we'll be covering the module one for today. And first, let's see what all are in the module. Okay, these all are the topics in the module. Okay, these are the syllabus. Okay, module one. Okay, so let's start. Change of form to okay. So let's start by to start by okay. Let's start by anyway, leave it. So introduction to networks. That's our first topic, and so So a wireless network is a flexible data communication system which uses wireless media such as audio frequency technology to transmit and receive data over the air, minimizing the need for wired connection. Okay, so basically, wireless network is a flexible data communication system, as we all know, which uses wireless media such as radio frequency, a frequency to transmit and receive data over the which uses radio frequency technology to transmit and receive data over the air, minimizing the need for a wired communication. Okay, just like the name says. Okay, then wireless network are used to augment. think so. Okay, anyway, leave it. So wireless network are you yeah. So wireless network are used to augment rather than replace. Augment, what do you mean by augment? Rather than replace wired network and are most commonly used to provide the last few stages of connectivity between a mobile user and wired network used. Okay, let me check what that actually means. So, so, wireless network are used to supplement rather than replace wired network and are mainly employed to provide last mile connectivity between mobile user and wired network. Okay, are mainly employed to provide last mile connectivity. Yeah, right. Between mobile user and the wired network. Okay, that also makes sense. Wireless network are wireless wireless networks use electromagnetic. So wireless network use electromagnetic waves to communicate information from one point to another without relying on any physical connection. Okay, uses electromagnetic waves to communicate information from one point to another without relying on any physical connections. Okay. Radio waves are often referred to as radio carrier because they simply perform the function of delivering energy from remote to receiver. Radio waves are often referred as radio carriers. Okay. Radio waves are often referred to as radio carriers because sim they simply perform the function of delivering energy to a because they simply perform the function of delivering energy to a remote receiver. Because they primarily serve to transfer energy or information from to a better rephrased one is I think radio waves are called radio carriers because they primarily serve to transmit energy or information from a transmitter to a remote receiver. Okay, radio waves are called radio carriers because they primarily serve to transmit energy or information from a transmitter to a remote receiver. Okay, that also makes sense. Okay. The data being transmitted is superimposed to the radio carrier so that it can be accurately extracted at the receiving end. Okay, the data being transmitted is superimposed on the on the radio carrier so that it can be accurately extracted at the receiving end. Once data is superimposed or modulator onto the radio carrier, the radio signal occupies more than single frequency, since the frequency or the bit rate of the modulating information adds. uh, I think that's also a bit complex. Let me simplify it. So the transmitted data is superimposed on the radio carrier. Radio waves are called radio carriers because they primarily tra- serve to transmit energy or information from. Okay, okay. Is superimposed to the radio carrier so it can be accurately recorded at the receiver end. When data is modulated onto the carrier, the data is onto the carrier, the resulting radio signal occupies a range of frequency rather than a single frequency. Because of the frequency or a bit rate of information, signal adds to the carrier frequency. So basically, the transmitted data is superimposed to the radio carrier, so it can be accurately recorded at the receiver. Okay, so when data is modulated onto the carrier, the resulting radio signal occupies a range of frequency rather than a single frequency. Because of the frequency or the bit rate of the information, signal adds to the carrier frequency. It doesn't make any sense. Because the frequency or the bit rate of the information signal adds to the yeah, exactly. So it's clear simple. Like we are adding extra more data uh, to the carrier signal. That's why the resulting final signal will be much heavier. Like we will be having a range of frequency. If the range of frequencies are getting occupied later on the carrier, data is modulated onto the carrier and resulting range of frequency rather than single frequency because of the frequency or bit rate. It adds on the carrier frequency. That's straightforward also as well. Okay. Multiple radio carriers can exist in the same space at the same time without interfering with each other if the audio waves are transmitted on the different radio frequencies. Okay, that's also pretty straightforward. Let me try to rephrase. Multiple radio carriers, multiple radio carriers can coexist in the same space without causing interference, provided they are transmitted at different radio frequencies. So, if the radio waves are or the radio carriers are okay, different, okay, we can have multiple Multiple radio carriers can coexist in the same space without causing interference. Okay, so two radio, yeah. So that means you can send two carriers at the same time without causing any interference if we are able to send it in two different radio frequencies. Like like so we can take the example of mobile communication. Like when we call someone, or the two different people won't be having the same conversation. Like they won't be hearing our conversation. Okay, that's it. To extract data, a receiver tunes in one radio frequency while rejecting all other frequency. The modulated signal thus receive is then demodulated and the data is read from the signal. Okay, let's also rephrase it. Like, this one is actually simple. Okay, tunes. So to extract data, a radio frequency tunes to extract the data, a radio receiver tunes to a specific radio frequency while rejecting other frequencies. The received modulated signal is then demodulated to recover the transmitted data. So here we have said that the data is getting modulated onto the carrier. So when we are receiving, we receive the modulated signal, and that modulated signal is getting demodulated. Okay, that also makes sense. Okay. Wireless network offers following productivity, convenience, and cost advantage over traditional wired networks. First one is mobility. Yes. Second one is storage simplicity, reach of network, flexible, reduced cost of ownership, and lastly, scalability. So, wireless network offers following productivity, convenience, and cost advantage over traditional wired network. Okay, productivity, convenience, and cost advantages. The first one is mobility. Okay, don't need to mobility. So provide mobile users with access to real-time information. Provide mobile users with access to real-time information so they can roam around in the network without getting disconnected from the network. This mobility supports productivity and ser- uh, service. Yes, and service opportunities not possible with wired network. Okay, is installation speed and simplicity. Installing wireless system can be fast, easy, and can eliminate the need to pull cable through walls and ceilings. So it's a convenience. Okay. Next is reach of the network. The network can be extended to places that cannot be wired. Yeah, extend to places where, okay, maybe we can connect to different mountains or valleys. We can connect using wireless connection. More flexibility. Wireless network offer more flexibility and adapt easily to changes in the configuration of the network. Okay. Reduce cost of ownership. Okay. While the initial investment requires for the wireless network hardware can be higher than the cost of wired hardware, overall installation expense and the life cycle cost can be significantly lower in dynamic environments. Okay. And lastly, scalability. Wireless system can be configured in variety of topologies to meet the need of specific application and installations. Configuration can be easily changed, and the range of peer-to-peer network suitable for small number of users to large infrastructure network that enable roaming over broad area. Okay. So, wireless network provides several productivity, convenience, and cost advantages over traditional wired network. And the first one is mobility. Wireless network allow mobile users to access real-time information while moving within the network without losing connectivity, thus improving productivity and enabling services not possible within the wired network. Second, installation speed and simplicity. Wireless systems are quick and easy to install and eliminate the need for running cables through walls and ceilings. Network reach. Wireless network can extend connectivity to locations where wired connections are difficult or impossible to implement. Next one is flexibility. Wireless networks are highly flexible and can easily adapt to change in network configuration. Reduce cost of ownership. Although initial hardware cost may be higher, installation and long-term maintenance costs are often lower, especially in dynamic environments. Scalability. Wireless networks support various topologies and can be easily expanded, ranging from small peer-to-peer network to large infrastructure networks supporting wide area roaming. Okay, I like this version and I will be replacing it. Okay, okay, mobility, and here we go. Installation and simplicity. For reach, ability, cost of ownership, lastly scalability. Okay, wireless networks support various topologies and can be easily expanded, ranging from small peer-to-peer network to large infrastructure networks supporting wide area roaming. Okay, that's also a good thing. So that concludes the introduction to wireless networks. Okay. So introduction of wireless network is completed, and let's have a quick recap. So wireless network is a flexible data communication system which uses radio frequency technologies to transmit and receive data over the air, minimizing the need of wired communication. Wireless networks are used to supplement rather than replace the wired network and mainly employed to provide last mile connectivity between mobile users and wired infrastructure. So wireless networks use electromagnetic waves to communicate information from one point to another without relying on any physical connection. So radio waves are called radio carriers because they are primarily serve to transmit energy or information from a transmitter to a remote receiver. The transmitted data is superimposed onto a radio carrier so it can be accurately recovered at the receiver. When data is modulated onto the carrier, the resulting radio signal occupies range of frequency rather than a single frequency because the frequency or the bit rate of the information signal adds to the carrier frequency. Okay, so multiple radio frequencies can coexist in the same space without causing interference, provided they are transmitted at different radio frequencies. And to extract the data, a receiver tunes to a specific radio frequency while rejecting other frequency. The received modulated signal is then demodulated to recover the transmitted data. Okay. So the main advantages of using the wireless network are productivity, convenience, and cost advantages. Okay, over the traditional network, for example, mobility. Wireless network allow mobile users to access real-time information while moving within the network without losing connectivity, improving productivity and enabling services not possible within wired network. So, for example, like we are talking on a mobile phone, like we can roam around the house, we can video call and things like that can be done easily with the help of wireless connection. Next is installing speed and simplicity. Wireless systems are quick and easy to install and eliminate the need for running cables through walls and ceilings, as we all know. Network reach. Wireless networks can extend connectivity to locations where wired connections are difficult or impossible to implement. Okay, and flexibility. Wireless networks are highly flexible and can be easily adapted to changes in network configuration. Although initial hardware costs may be higher, a higher installation and long-term maintenance costs are often lower, especially the dynamic environment. Scalability. Wireless networks support various topology and can be easily expanded, ranging from small peer-to-peer connection to large infrastructure networks supporting wide area roaming. So our next is wireless transmission. Helix, no, bold, totally helix. Okay. So next portion is wireless transmission and frequencies of radio transmission. So frequencies for radio transmission. Okay. So next topic. I hope so. Frequencies of radio transmission. Okay, anyway, let's get back to the topic. So frequency for radio transmission. That's our next topic. We could stop it. We need to finish full. Okay. So first is radio transmission. Radio transmission can take place using many different frequency bands. Okay, each frequency band has a certain advantage. And each frequency band exhibits a certain advantage and disadvantage directly coupled to frequency is the wavelength lambda via the equation lambda equals c by f, where c approximately equal to 3 ms and the speed of light in vacuum and the frequency f. Okay. Radio transmission can occur over different frequency bands. Each radio transmission can take place in different frequency band, having its own advantages and disadvantages. It's directly related to frequency by the equation lambda. C is approximately 3 into 10 raised to 8 milli per second, the speed of light in vacuum. So radio transmission can occur over different frequency bands, each having its own advantages and disadvantages. The wavelength lambda is directly related to the frequency by the equation lambda equals to frequency by c, where c is 3 into 10 raised to 8 meter per second, which is the speed of light in vacuum, and f f f f is the frequency. Okay, it and f is the frequency. Okay, simple. For traditional wired network frequency, for traditional wired network frequencies of up to several hundred kilo. In traditional wired network, frequencies up to several hundred kilohertz are used for communication over distance of a few kilometers using twisted pair copper wire, while frequencies of several hundred megahertz are used when coaxial cables are employed. Didn't get that part. In traditional wired network, frequencies up to several kilohertz. Several hundred kilohertz are used for communication over distance of a few kilometers using twisted pair copper wire, while frequencies of several hundred megahertz are used when coaxial cables are employed. So, while fiber optic communication operates at frequencies in a range of several hundred terahertz, I guess it is terahertz. Terahertz, yeah. Terahertz frequency range. Yeah, fiber optic communication operates at a frequency in a range of several hundred terahertz. However, it is commonly described in terms of wavelengths such as 1500 nm or 1350 nm, etc. Okay. Yes, it in the figures of nm. Nanometer. Okay. However, it is commonly described in terms of wavelengths such as 1500 nanometer or 1350 nanometer. Okay. This ranges several hundred terahertz. However, it is commonly described in terms of wavelengths such as 1500 nanometer or okay. Radio transmission starts several kilohertz. Radio transmission begins at several kilohertz in very low frequency range, which consists of long waves. Low frequency waves are used for submarine communication because they can penetrate water and follow a surface. Some radio broadcasting stations also operate in this range. For example, between 100 148.5 kilohertz to 283.5 kilohertz. So, radio transmission frequency begins kilo several kilohertz. So, radio transmission begins at several kilohertz in very low frequency range, which consists of very long waves. Low frequency waves are used for submarine communication because they can penetrate water and follow a surface. Some radio transmission low frequency range, very long. These are very long waves, and waves in the low frequency range are used in submarine because they. So radio transmission begin at several kilohertz, several kilohertz. Even twisted several application also happens very low frequency. Several kilohertz. Low frequency range which consists of very long waves. Low frequency waves are used for submarine communication because they can penetrate water and follow a surface. Some radio broadcast stations also operate in this range. For example, between uh, 148.5 kilohertz to 283.5 kilohertz. Okay, okay. So radio transmission frequency begins r- at several kilohertz in very low. So begins at several kilohertz, like 1, 2, 3, 4, in very low frequency very low frequency range, which consists of long waves. Low frequency waves are used for submarine communication because they can penetrate water and follow Earth's surface. Some radio broadcasting stations also operate in this range. For example, between 1400 kilohertz to it was okay. That's correct. Correct. So the medium Frequency and high frequency ranges are commonly used for radio broadcasting. Transmission occur using ap- amplitude modulation between 520 kilohertz and 1605 kilohertz. Short wave transmission between 5.9 megahertz and 26.1 megahertz, and frequency modulation between 87.5 megahertz and 108 megahertz. Okay, these are the ranges in which like transmission happening, like medium frequency and high frequency range. The frequency limits of these ranges are usually defined by national regulations, and many vary from country to country. Short frequencies are used for amateur radio communication worldwide, as they travel long distance by reflecting off the ionosphere. Okay. Analog television transmission operates in the very high frequency, and that is 1174 to 230 megahertz, and the ultra high frequency band, that is 470 to 790 megahertz. Within these range, digital audio broadcasting also operates at 223 megahertz and 1042 megahertz. Okay, 1472. Digital television services are planned or currently deployed in 40 range using some frequencies previously allocated for analog TV transmission. Okay, an ultra high frequency band. This range the audio broadcasting take place as well, and currently being installed. Ultra high frequency band is also used for mobile communication system. It includes analog mobile phone services. Okay. Ultra high frequency band is also used for mobile communication system. It includes analog mobile services, digital systems, digital cordless telephone based on DECT standard, 3G cellular systems using UMD standards. Okay. Super high frequencies are commonly used for direct and microwave links in the range of approximately 2 to 40 gigahertz for fixed satellite communication services operating in the C band, that is 4 and 6 gigahertz, KU band 11 and 14 gigahertz, and KA band 19 and 20, like some figure of numbers. Some communication systems are planned to operate in the extremely high frequency range, which lies close to the infrared region of the electromagnetic spectrum. Okay, all radio frequencies are regulated to prevent interference between different communication systems. Okay, the International Telecommunication Union, located in Geneva, is responsible for worldwide coordination of telecommunication activities, including both wired and wireless communication. The ITU is specialized agency for United Nations. The ITU radio communication sector is responsible for standardization of wireless communication and managing frequencies planning, formerly known as Consulting Committee for International Radio (CICR), for effective global coordination and accommodate national interests. The were in three regions. Region 1, Europe, Africa, Middle East, Greenland. Okay. I don't think that's so much importance. Like, we just need to know that there are three regions. There is an International Telecommunication Union is there, and it is located in Geneva, and it is responsible for the worldwide coordination of telecommunication activities. Okay. That this concludes our wireless transmissions. Next is signals. Okay, next is signals. Electromagnetic signals are used as a means of means to transmit information. An electromagnetic signal is a function of time, but it can be expressed as a function of frequency. That is, signal consists of components of different frequencies. Electromagnetic signals are used to transmit information. An electromagnetic signal can be represented as a function of time or a function of frequency, meaning that the signal is composed of multiple frequency components. And are used to transfer information. Signal can be represented as a function of time or a function of frequency, meaning signal is composed of multiple frequency components. That signal consists of or different frequencies. Think the meaning got changed over there. So electromagnetic signals are used as a means to transmit information. An electromagnetic signal is a function of time, but it can also be expressed as a function of frequency. That is, the signal consists of components of different frequencies. Okay, signals are a physical representation of data. Users of a communication system can only exchange data through the transmission of signals. Okay, signals are a physical representation of data. Users of a communication system can only communicate system can only exchange data through transmission of signals. Layer one of ISO OSI base is responsible for conversion that layer one of the say refers reference ISO or OSI. Why this confusion? The layer one of the OSI reference model, known as physical layer, is responsible for converting data into signals, for transmitting and converting data into signals, for transmission and converting received signal back into bits. Signals are functions of time and location. Signal purpose. Signals are functions of time and location, and their parameters represent the data value being transmitted. Okay. Most interesting type of signals for radio transmission are periodic signals, especially sine waves as carriers. The most interesting type of signals for radio transmission are periodic signals, especially sine waves as carriers. The general function of a sine wave is G T T A T. The general mathematical representation of the sine wave is g of t equal to a sine 2 pi f t plus 5, where a is the amplitude, that is maximum strength, f is the frequency, number of cycles per second, t is the time, phi is a phase angle, the phase shift of a signal. Okay, this equation describes how a sinusoidal signal varies with time. Okay, anyway, leave it. This describes sinusoidal waves. Okay. Sine waves are important because any periodic signal g of t can be represented as a combination of sine and cosine function according to the Fourier theorem. Fuck Fourier theorem. G of t equal to c by 2. Okay. So sine waves are important because any periodic signal g of t, can be represented as a combination of sine and cosine function according to the Fourier theorem. So g of t equal to 2 a represent sine wave. Okay. Yeah, you can for a g of t equals c by 2 plus um, summation of in summation of n equal 1 to infinity a by n sine 2 pi nft plus bn cos 2 nft. This parameter c represents the direct current. Okay, this parameter c represents direct current dc current component of the signal. The coefficients a n and bn represent the amplitude of the nth sine and cosine component. Okay. Uh, this equation shows that an infinite number of sine and cosine waves are required to construct any arbitrary periodic signal. The frequency of these components are called harmonics. Increase with increasing in nth function n and multiples of the yeah, whatever. So since okay, C represent direct current component and coefficient represent amplitude of the nth component. This equation this equation shows that an infinite number of sine and cosine waves are required to construct a arbitrary periodic signal. The function of these components called harmonics increase with increasing n and are multiples of fundamental frequency f. The equation shows that a finite number of number of sine and cosine functions are needed to construct arbitrary periodic function, and frequency of these functions increases with the growth of parameter n and the multiple of the and are a multiple of the fundamental frequency f. Okay. called frequency of these components. Okay. The equation shows that a finite number of sine and cosine functions are needed to construct an arbitrary periodic function. The bandwidth of any transition medium, such as air, cable, or transistor, is limited. Therefore, there is an upper limit to the range of frequency that can be transmitted. The bandwidth of any transmission, such as air, cables, or transmitted. Okay, all transistors. The bandwidth of any transition medium, air, cable, or transistor is limited. Therefore, there is an upper limit to the frequencies that can be transmitted. All transmission systems have a bandwidth limitation and cannot transmit arbitrary periodic signal perfectly. Okay, we have mentioned about arbitrary uh, periodic signal. Okay, periodic signal. Signals are commonly represented in a time domain where amplitude amplitude A of a signal is plotted against time, and time is usually measured in seconds. And the amplitude may be measured in units such as volt. This form of representation is typically observed using oscilloscope, where signal variations over time can be analyzed, including amplitude and phase characteristics. Okay. In a frequency domain representation of a signal, the amplitude of a certain frequency part of signal is shown versus. In the frequency domain representation of a signal, frequency domain representation of. In frequency domain representation of a signal, amplitude of each frequency component is shown as frequency as a function of frequency, indicating how much of each frequency is present in the signal. Okay. Arbitrary periodic function would have many peaks known as frequency spectrum of a signal. Arbitrary periodic signals contain multiple frequency components, which appears as peak in the frequency spectrum of the signal. A spectrum analyzer is used to display and analyze these frequency components. Fourier transformation is a mathematical technique used to convert signal from time domain to frequency domain, while the inverse Fourier transformation converts it back from the frequency domain to time domain. A third method of representing signal is the phase representation known as phase state. Okay. A third method for representing signals is the phase representation, also known as phase state or the signal constant constellation diagram. The constellation diagram, it represents the signal using polar coordinates shown as phase of the signal. Okay. The third method to represent signal is the phase representation, also known as phase state or a signal constellation diagram. We need to add diagrams for these things. As a function of time, electromagnetic signal can be either analog or digital. Analog signal is one of the single ana- an analog signal is one of which the signal intensity varies with smooth fashion over time without any break or discontinuity of signal. A digital signal is signal intensity maintains constant level for some period and then changes to another constant level. Analog signal might send speech and digital signal might represent as binary 0 1. Simplest sort simplest sort of signal is periodic signal in which same signal pattern repeats over time. So here T is a constant and okay, constant level, and generally you can represent in three parameters: peak, amplitude, frequency, and five phase. Okay. Peak amplitude is the maximum value of strength over which time is measured in volt. Peak frequency is the rate in which okay phase is measured in sine wave can be written as phase function of waveform in the equation known as sinusoid. The wavelength of a signal is said wavelength A of a signal in the distance occupied the single cycle output another way distance between 2 points from corresponding phase or two consecutive circles. Okay. Next is time domain. When viewed as a function of time, an electromagnetic signal can be either analog or digital. An analog signal is one in which the signal intensity varies smoothly over time without any break or discontinuation. That's correct. Okay. A digital signal. An analog signal typically represent continuous information such as a speech, while digital signal represent discrete data values such as binary, 0 and 1. simplest type of signal is a periodic signal in which the same signal pattern repeats continuously over time. Okay. A signal S of t to be periodic if S of t plus t t is the periodic signal, t is the period of the signal. If this condition is not satisfied, then the signal is aperiodic. To be periodic if and only if S plus uh, where t is the period of the signal. If the condition is not satisfied, the signal is aperiodic. A sine wave is the fundamental analog signal and it is with the parameters amplitude, frequency, and phase phi. Okay. Amplitude is a maximum. Into 1 by f. Okay. Time period is required to complete one cycle given t by and indicated by waveform in a single witness. The general sign are expressed as and the wavelength and I think the same education describes sinusoidal time. Yeah, sinusoidal wave and same thing. Okay, that's completed. So signals completed. Now antenna and signal propagation. Antenna, I don't think we can do that because okay, I think we can do a quick recap on things that we need to cover next day. I think we will stop by signals for today. These are the topics remaining. Okay. Okay, next one will be antennas. Antennas can be defined as an electrical conductor or a system conductor used to either for radiating electromagnetic energy or collecting electromagnetic energy. Okay. Isomorphic antenna types. Okay, different types of antennas are there. Antenna gain is there. Then we have signal propagation. Network signal has no wire to determine the direction of propagation, whereas signal in a wide network only have travel. Okay, as long as signal is not interpreted damaged. Okay, transmit range interference. Okay, path loss signal. Okay, skyway protection. Additional propagation effect. Okay, multi-path propagation. Okay, then we have the multiplexing. One of the important thing we have multiplexer, space division multiplexing, frequency division multiplexing, time division multiplexing, code division multiplexing. Then we have modulation and then a frequency division multiplexing, median characteristics, amplitude shift key. Okay, frequency shift key. Okay, phase shift key. Okay, okay, okay. The basis of phase shift key. Okay, we will have quantum multi-carrier modulation. If you modulate reverse or multi-carrier modulation, orthogonal division. So then we are going to the spread spectrum. Okay, so long module, I guess. Not a long module, but so many nodes. Okay, let's read the questions also. What are the main benefits of spread spectrum systems? Describe in details the operation of direct sequence spread spectrum with need diagram. How MAC scheme used in CDM to assign certain codes to allow separation of user in code space, right? With an example. MAC is modulation. MAC, what is this? MAC. I have heard MAC somewhere. CDM code division multiplex. Multi-carrier modulation. Yeah, we could have right. Oh yeah, that was also in MCA. Okay, fuck, bro. Yeah, describe details. Describe details advantage frequency shifting key modulation. Advanced frequency shift modulation. Oh, that was a fucking simple question. Was that shit? That was a simple question. Okay. Name the GSM system architecture with an ES diagram. Oh, that was also simple. Okay, describe the architecture of GPS. Actually, the paper was simple as fuck. All these things still we have the time. We can try going through all these. We can finish in time. Okay, that's all, folks. We can catch tomorrow. Thanks for watching.